So -3 pi. So you would rotate to pi, that's like this far, but you would go -3. So that would put you this direction 3. So what is that coordinate point in rectangular? 3, 0. So I made it land on the axis to make that a little bit easier for you. Yeah, and you can work it out too. So 0, -5 would be like down here. So if you're going to write that as r theta, well, the radius is 5, you're 5 units away. How far did you rotate? Good. Did you put -pi/2? I would have to accept that as a correct answer. There's like a multitude of correct answers. Do you know what I'm saying? Because an infinite amount, because you could keep rotating around and around. I mean, like, I hope you would do either 3pi/2 or -pi/2, but right. But I can time you and then take it from you when you run out of time. Are you okay, Jenna? Yeah, I would just draw it. All right, so for this one, we're going from 0 to 2 pi. Make a table of values here. We're going to start at 0 pi. Now, because there's do you see this 2 inside of there? So instead of just doing the quadrant angles, I'm going to do like by fourths. Here's my pep talk. It's not that big of a table of values. You're going to be okay. It's 9 values to plug in. You're going to be all right. I promise. All right, so if we go to plug in 0, cosine of 0 is 1 times 2 gives you 2. If you plug in pi/4, when you multiply that by 2, you would get pi/2. Cosine of pi/2 will be 0. All right, when you plug in pi/2, the 2's cancel. Cosine of pi is -1 times 2 is -2. When you plug in 3 pi/4, multiplying that by 2 is going to give you 3 pi/2. Cosine of 3 pi/2 is 0. Every other one is going to be 0. Okay. Plugging in pi, cosine of 2 pi is 1 times 2 is 2. This next one's going to be 0. Once you like establish a pattern, you can kind of just keep it going. Plugging in 3 pi/2, the 2's are going to cancel. 3 pi is in the exact same place as pi. Cosine of pi would be -1 times 2 is -2. Do you see a pattern? 2, 0, -2, 0, 2, 0, -2, 0, 2. Again, once you get the pattern going, you can kind of just continue it because it's cyclic. All right, so 0 pi 2, that's going to be right here. You haven't rotated anywhere, so here's 0 pi. We went 2 in that direction. And then the pole, so 0. It doesn't matter what the angle is. If your radius is 0, you're at the origin. All right, pi/2 would be up here, but we went -2, so it's going to be down here. And if you want to like start to connect these, we started here. We're going to go through the origin and then come down here. Sometimes like it's not good to wait until the very end to connect them, because then you end up with this like constellation of points and it's like, where on earth do I connect them? So we started here, went through 0. Now we're back to the pole. That's our first like petal there. Pi 2, that's going to put us right here. and then back to 0. Are you guys seeing what it's going to look like? So, like, could you just keep it going? Again, like, my hope is that at a certain point you would like just go, oh, okay. Like, that's what it's going to look like. And do you see how we have a 2 theta and we got 4 petals? Like, it was double that number. It's cute, little 4-leaf clover. It's so cute, cute little graph. All right, that's like what we did last time. Now we're getting into the derivatives. Find the derivative dy dx. All right, it's a little bit of writing, but it's not necessarily hard. First, you have to find y and x to do dy dx. So y is r sine theta. So it's going to be this times sine theta. X is going to be this times what? Cosine theta. Now that one I would simplify down. You know how secant and cosine are reciprocals? Do you get what I'm saying there? One of them is going to cancel. And so it'll just be secant of theta. Like if you have secant times cosine, that would just be 1. It's just we had an extra secant in there. All right, so dy dx. We're going to do this derivative first. It's a product rule. They mostly are. So first times derivative of the second plus second times derivative of the first. Now that involves a chain rule. You would bring the 2 down. It would drop to the first, and then you have to chain on the derivative of secant. So what is your derivative of secant? Secant tangent? That's really long, but who cares? It's fine. Over, and now we're going to do the derivative of x. Catch a break there because it's just secant. Derivative of secant? Secant tangent. Please, for my sanity, do not try to do anything to that. It's honestly easier for me to grade if you leave it alone because I can check each individual step of it. Like just leave that and walk away. Question? Or are you okay? Okay. All right, what is the slope of the tangent line? That means derivative at 3 pi over 2. So you're going to do the exact same thing we did here, except then plug in pi over 2. You're just going to do the derivative at that value. All right, so first we need to find y and x. Y is going to be this, what was it, 3 plus cosine, times sine, and x is going to be that times cosine. So again, we're going to do the derivative. It's going to look like a mess, but then we're just going to plug in 3 pi over 2 and evaluate it. And yes, I want you to evaluate the trig. Don't leave it as sine of 3 pi over 2. Like that's kind of what I'm quizzing you on, right? So we're going to do the derivative of this one right here. It is a product rule. So first times derivative of the second plus second times derivative of the first. 3 is a constant. Derivative of cosine will be negative sine. Over, now we're going to do the derivative of this one. It's going to be nearly the exact same thing, right? First times derivative of the second. That'll be negative sine plus second times derivative of the first, which will also be negative sine. And then we're just going to plug in 3 pi over 2. Where's 3 pi over 2 on your unit circle? Like down there says 0, negative 1. So this is cosine, and this is sine. So everything's going to be zeros and negative 1s, okay? Let's just go ahead and plug it in. Cosine just said that was 0 plus 3 is 3. Cosine, we just said that was 0. plus sine, what did we just say that was? -1. Here it would be -1, so just 1. Down here, cosine is 0, plus 3 is 3. Sine is -1, negatives cancel, so that'll just be 1. And then this would be 0 times 1. There you can stop. You don't have to simplify that down. And I suggest you don't, because if you accidentally add or subtract wrong, it's going to be wrong. All right, last one. At what values of theta does r equals cosine of theta have a vertical tangent line? What do you set equal to 0 for vertical tangent line? Good. So first we need x, and then we'll find dx d theta, and then we'll set it equal to 0. So x is going to be what? That times cosine, which would be cosine squared. Good. So doing that derivative, you would bring the 2 down. It would drop to a 1, and then you have to chain on derivative of cosine, which would be negative sine. And again, we're setting it equal to 0. The negative is not going to matter because 0 divided by -1 is still 0. The 2 is not going to matter for the same reason. You're just going to set each of those equal to 0 and solve them from 0 to pi. So where would cosine, the x value on your unit circle, be 0? Pi over 2, and also 3 pi over 2, but that's outside of the window. And for sine, it would be 0 pi and 1 pi.